Our solar system is a savage place, from the ice volcanoes of Saturn's moon Enceladus to the vast lava fields of Jupiter's moon Io, and even here on Earth. Volcanoes destroy, but they also create. It's literally true that if there weren't volcanoes, we wouldn't be here either. Volcanoes shape and change our climate. They are the givers of life and also the takers of life. Today's space probes and telescopes reveal volcanoes on worlds we once thought were dead. Discovering volcanoes on an object smaller than our moon was a huge shock. If volcanoes exist on other worlds, could we find life there too? Planet Earth, a jewel in the darkness of space. Our home is timeless, beautiful, and incredibly violent. Volcanoes are one of the most powerful natural phenomena on the planet. They create new land and destroy the old. They blast out gases that transform the air we breathe. Deep in our oceans, volcanic heat fuels strange new life. Volcanoes help power the living Earth. Now, we search for signs of life on alien worlds. We know life needs water, and we know it needs energy. That's where volcanoes come in. They pump out vast amounts of energy. Find volcanoes on other worlds, and we might find life. The search starts here, on the planet orbiting closest to Earth, Venus, a world that appears very much like ours. Venus and Earth are roughly the same mass, and they're roughly the same distance from the Sun, so they're kind of like twins. 3 billion years ago, Earth and Venus were very similar: new land, new oceans, an atmosphere. Both planets were perfect for life. But something went wrong on Venus, something that caused Venus to diverge radically from Earth's history. Venus took a definite turn to the dark side a long time ago. Venus is a hellhole, our evil twin. Today, Venus's surface is like a furnace. It's 900 degrees Fahrenheit on the surface, hot enough to melt some metals, so you wouldn't stand a chance. Venus is a greenhouse world, its atmosphere thick with carbon dioxide. It traps heat from the sun like a blanket. These actual images of Venus's surface reveal a barren, superheated wasteland. Venus's thick blanket of carbon dioxide killed the planet. The carbon dioxide came from volcanoes. Orbiting space probes gave the first clues. Radar pierced Venus's thick clouds and revealed volcanic formations across the planet, similar to those we see on Earth. The shield volcanoes of Hawaii get their name from their round, flat shape. These volcanoes ooze, but they ooze for thousands of years. Once we were able to map the entire surface of Venus using cloud-penetrating radar, we began to study the landforms and saw a lot that was familiar. In particular, we saw giant shield volcanoes very similar to those in Hawaii. The radar images of Venus were dead ringers for Hawaii's shield volcanoes. At some point in the past, Venus had volcanoes. For the first time, we had a picture of Venus revealed, and we were shocked. We found a scarred volcanic surface with at least 1,000 large volcanoes and maybe tens or even hundreds of thousands of smaller ones. 3/4 of Venus's surface is covered in lava plains, evidence of an ancient cataclysm. This could have been a home for life, but instead, it was engulfed by fire. Volcanoes belched trillions of tons of carbon dioxide into Venus's atmosphere. Temperatures soared, and the seas boiled dry. A runaway greenhouse process began. On Earth, carbon dioxide is absorbed by rocks and the ocean, but on Venus, there's no water, and it's so hot that carbon dioxide can't combine with rocks. So, as volcanoes released carbon dioxide long ago, there was no way to remove it from the atmosphere. If Venus ever had life, volcanoes sterilized the entire world. Earth remains the only living world we know of, but that may change. This is the gas giant Jupiter, with its moons, frozen and dead, or so we thought. Look closer, and a mystery emerges, a cloud hanging over what seems to be a cold, lifeless world. On Venus, volcanoes turned an Earth-like world into a superheated hell. Finding volcanoes on an Earth-like planet wasn't a surprise, but spotting volcanoes on a moon was a shock. In March 1979, the Voyager 1 space probe gave us our first close-up view of Jupiter's tiny moon Io, a world we once thought cold, old, and dead. They saw something strange, an arc next to the moon, which looked like another moon behind it. We scratched our heads and wondered what it could be. Everybody knew Io was dead, boring, and uninteresting. But then, people realized it was a volcanic eruption. We found that Io was covered with volcanoes and was incredibly geologically active, with constant volcanic eruptions. What erupts from these volcanoes is primarily sulfur, which changes color with temperature. Sulfur can be red, orange, yellow, or black, making Io's surface resemble a pizza with different cheeses and black olive spots. Io is not dead, it's alive and kicking with over 400 active volcanoes. The largest plumes erupt from gigantic lava lakes, reaching nearly 250 miles into space. If we could stand on the edge of one of these lava lakes and watch the plumes shooting off into the blackness of space, it would be an incredible sight. Io's eruptions are so huge because it's such a small moon, there's nothing to hold the lava back. It has virtually no atmosphere and very little gravity, making Earth's volcanoes seem like firecrackers by comparison. How can such a tiny moon be so volcanic? The answer is Jupiter. Just as the moon raises tides in Earth's oceans, Jupiter raises tides on Io, tides made of solid rock. Io's orbit around Jupiter isn't a circle, sometimes it's closer, and sometimes farther away. Jupiter gives Io a gravitational pounding, pulling on it harder and softer, stretching the moon. This stretching creates a tidal force. It's not a large stretch, but it's enough to heat the moon through friction, just like how rubbing your hands together generates warmth. Jupiter's gravity stretches and squeezes Io during every 2-day orbit, causing the ground to rise and fall by nearly 300 feet. This pummeling generates intense heat and massive pressure. Wherever there's a weak spot in the crust, lava rushes out, resulting in planetary-scale volcanism. Unlike Earth, where volcanic activity is concentrated in certain areas around tectonic plates or weak spots, the entire moon of Io is one active hotspot. Thanks to the incredible power of gravity, Io is the most volcanically active world in the solar system. Io's volcanism taught us something new, that internal sources of energy can drive volcanic activity in ways different from those on Earth. In outer space, tidal forces, the differential squeezing of moons by a gas giant, can also create volcanic activity. This was a game changer. Io is a world of lava, superheated and violent, and it's hard to imagine anything surviving there. Yet, the volcanic principle here is the same as on Earth: pressurized, superheated magma beneath the surface blasts through fissures in the crust. But not all volcanoes need magma, and they don't even need to be hot. Travel farther out beyond Jupiter into the outer solar system, and it gets cold, really cold. The distant moon Triton is so cold that much of its thin atmosphere can freeze solid. Yet, there are volcanoes here, volcanoes that may hold the secret to alien life. We think of volcanoes as mountains of solid rock, with superheated rock beneath that bursts violently out as lava. But not all volcanoes work this way. There are volcanoes on other worlds that don't use molten rock at all. At the edge of the solar system, Triton orbits the ice giant Neptune, 2.5 billion miles from the Sun. The temperature is a frigid -390 degrees Fahrenheit. When NASA's Voyager probe flew past it, it revealed a world mostly covered in frozen nitrogen ice. But the probe found something else. When Voyager flew by, it saw black smudges, all moving in one direction, as if a wind were blowing dark material in that direction. This was a sign of activity on a world so cold that nitrogen can freeze solid. Forget molten rock, Triton spews a mixture of nitrogen and moon dust. The geysers not only release liquid nitrogen in fluid form, but also a lighter, dusty material that can travel farther in Triton's weak winds. This creates a double plume effect, one part icy and the other darker and dustier, like moon dust. Triton's surface is made of nitrogen ice, but beneath that ice, there are lakes of liquid nitrogen. Scientists believe this happens because nitrogen ice allows light in but traps heat, creating a kind of greenhouse effect. Just like on Earth, where glass lets light through but traps heat, the sun shines through Triton's surface, warming the nitrogen beneath. Just a few degrees of warming are enough to turn nitrogen ice into gas. A temperature gradient, a change in temperature, is what's important, and that's enough to melt the nitrogen beneath Triton's surface and cause it to burst through as a geyser. This is a cryovolcano, so cold that the material it erupts would freeze water as hard as rock. The solar system is more active than we ever imagined. We have found strange eruptions on many planets and moons, but so far, the only world where volcanoes are linked to life is ours, or so we thought. This is Europa, which orbits Jupiter nearly 500 million miles from the Sun. It's a frozen, 2,000-mile-wide ball of ice. From a distance, its surface looks smooth, but up close, it tells a different story. Jupiter's enormous gravity gives Europa a pounding, just like its neighbor Io. The surface heaves and flexes, creating ridges and deep crevices. When we first received close-up images of Europa, they looked somewhat familiar. It turns out Europa's surface resembles ice floes seen when flying over the Arctic. It has a several-mile thick shell of ice, and beneath it, there is a global liquid ocean. Magnetic readings suggest Europa has an ocean that is an astonishing 60 miles deep. Jupiter's gravitational forces heat Europa's rocky core and melt the ice above. It's not unreasonable to think that as the core is stretched and heated, it may even become molten, with a boundary between the hot core and the liquid water ocean. On Earth, underwater eruptions are surrounded by life. The same could be happening on Europa. In Europa's ocean, the darkness is total, and the pressure is a crushing 2,000 Earth atmospheres, a brutal world, but perhaps a cradle for life. If life began here on Earth, why not on Europa? The ingredients are all there, an energy source, volcanic activity, liquid water, and a rich hydrocarbon chemistry. We have this mixing bowl of ingredients that led to life on Earth 3.5 billion years ago, and similar conditions exist on Europa. So, some people suggest that if it happened here, why not there? Life on Europa would be challenging, but not impossible. On Earth, life exists in extreme conditions, searing heat, crushing pressure, and total darkness. Alien life on Europa might look surprisingly similar. If life exists beneath Europa's icy shell, it would likely be aquatic but eyeless due to the absence of light. They would probably use sonar to navigate their environment, and organisms might feed off the energy from the volcanic activity. Volcanoes on Europa could be the source of new life. It's even possible that Europa represents the norm, that this is how life-bearing worlds typically exist. Earth could be the exception. Think about it. Europa could be a template for billions of moons across the universe, each with liquid oceans. Suddenly, our horizons have expanded several billion times by studying the moons of Jupiter. What a shock! Our solar system alone has over 170 moons. Multiply that across the universe, and there are countless potential places where life might thrive. All it takes is liquid water and a source of energy, which volcanoes can provide, and they are everywhere. This is Saturn, located twice as far from the Sun as Jupiter. Yet, it too has volcanic moons, and like Jupiter's Europa, these moons could harbor life. One of the strangest worlds in our solar system is Saturn, with a ring system 600,000 miles wide and an amazing 62 moons, one of which holds a secret. Enceladus is one of Saturn's smaller, more distant moons, and it has long been known that it is covered in ice because of its brightness and reflectiveness. But when the Cassini spacecraft arrived, it discovered something incredible, not on the planet itself, but on Enceladus. Backlit by the sun, a gigantic plume bursts into space, a sure sign of volcanic activity. It was an amazing discovery, helping to solve a long-standing mystery about Saturn's E-ring. Saturn's outermost ring is vast, nearly 200,000 miles across, and it shouldn't exist. The ice particles making up the ring are too far from Saturn to stay in orbit, constantly drifting into space. Something is replenishing the ring, the ice volcanoes of Enceladus. The plumes ejected from Enceladus' south pole aren't just dissipating into space, they're feeding Saturn's earring. This tiny moon is giving something back to its parent planet. Water blasts from Enceladus volcanoes, hits the vacuum of space, and instantly freezes into tiny ice crystals, creating Saturn's vast earring. One mystery solved, but another arises: what creates these volcanic plumes? Cassini's cameras zoom in on the moon's south pole and capture huge chasms scarring the surface. There are these enormous cracks at Enceladus's south pole, and as Enceladus orbits Saturn, these cracks open and close as the tidal forces pull. These cracks are hundreds of miles long, and when they open, they do so at up to 100 miles per hour. It would be an incredibly spectacular event. The enormous gravitational forces pull the surface open and closed at great speeds. Similar to the orbits of Europa and Io around Jupiter, Enceladus's elliptical orbit around Saturn helps generate heat, melting ice and creating oceans of liquid water beneath the surface. The conditions of the water underneath Enceladus are perfect for life. It's at the right temperature, with good pressure, and the water is similar to seawater here on Earth. The chemistry of the water ejected from these vents suggests it contains salt and organic material, making Enceladus a place in the solar system where life might exist right now. Cassini has detected complex carbon molecules in the ice plumes, and combined with liquid water, these suggest that life might survive deep within this enigmatic moon. Enceladus may not be alone in potentially harboring life. Another of Saturn's moons, Titan, might also hold the same potential. Titan is one of the largest moons in our solar system and the only moon with a thick atmosphere. It's a frozen world, with ice as hard as rock, and lakes of liquid methane. Yet here, too, we might find evidence of volcanoes and the tantalizing prospect of alien life. On Io, we see a raging inferno, and on Triton, eruptions of ice and nitrogen. Volcanoes are some of the most destructive forces in the universe, but out of destruction comes the possibility of life, even on Saturn's mysterious moon, Titan. Titan is 3,000 miles across, larger than the planet Mercury, and it's the only moon with a thick atmosphere. It has weather, storms, winds, rain, and even lakes. But because it is so cold, liquid methane takes the place of water, and it's loaded with the chemicals needed for life. Titan has turned out to be one of the most fascinating places in the solar system. It's an active world with an atmosphere much like Earth's, primarily made up of nitrogen and loaded with organic molecules. Methane gas in Titan's upper atmosphere reacts with sunlight to create the kinds of chemicals life depends on. But if sunlight is constantly converting methane into organics, why doesn't the methane run out? The atmosphere is full of methane, yet sunlight destroys it in a relatively short time. So, methane shouldn't be there unless something on Titan is replenishing it. Cassini has detected what looks like a crater, as deep as the Grand Canyon, and infrared cameras show different types of materials surrounding it. Scientists believe the green areas could be volcanic, with flows of material ejected from Titan's interior. If this volcanic activity exists, Titan's lava would be a super-chilled, icy slush, but compared to the rest of Titan, even this icy slush would be scalding hot. On Titan, the hot liquid spewing from volcanoes might be ammonia or water, which are usually frozen solid on the surface. But if they are heated beneath the surface, they could erupt. What comes out of Titan's volcanoes is methane and ethane, which is likely why Titan has such a thick cloud cover, an orange haze surrounding the moon. This haze probably came from outgassing from Titan's volcanoes. Even for volcanoes on a world as cold as Titan, you need heat. That's what turns ice into liquid and generates eruptions on Titan. That heat has two sources: radioactive materials warm the interior, and Saturn's huge gravity massages the moon, just like Enceladus. These two forces generate enough heat to turn ice into water and liquid methane into gas. We think of volcanoes as being hot and ice as cold, but if you're out on Titan, where you're a billion miles from the sun and it's quite cold, then flows of water ammonia ice, barely above freezing, might be the hottest things around. So, hot is a relative term, depending on where you are in the solar system. Could volcanoes on Titan give life a chance to survive? Life as we know it needs an atmosphere, a solid surface, liquid water, and heat to drive chemical reactions. On Titan, volcanoes could provide them all. If you have a volcano on Titan, you'll have heat. Add to that, and all of a sudden, you'll have liquid water surrounded by organic material, literally anything you need for the start of life. If life exists on Titan, it would be truly alien. It might breathe hydrogen instead of oxygen, perhaps swimming through lakes of liquid methane at 300 degrees below zero. Perhaps there are oceans of ethane, or tide pools, and volcanic or hydrothermal activity. Perhaps there are hot springs. Volcanic heat could generate enough energy to get life off the ground on Titan. It is speculation, but it cannot be ruled out. However, we may not need to travel this far to find signs of life. We may find it on a volcanic world much closer to home, the red planet, Mars. Volcanoes are everywhere across the solar system. Worlds like Io, Titan, and Triton are complex, dynamic, and violent. Once, we thought that Earth was the only planet with volcanoes and life. Now we find volcanoes everywhere, but we have yet to find alien life. Volcanoes embody the sheer power of creation and destruction, and they go hand in hand. It's literally true that if there weren't volcanoes here, we would not be here either. In the cauldrons of volcanoes is the origin of life. Volcanoes create new landscapes, seed the atmosphere with complex chemicals, and replace the old with the new. If volcanoes are tied to the processes of life, then where is the life on other worlds? Perhaps the answer lies in deep time, when the solar system was young, on a young planet much like our own. This is Mars, 3 billion years ago. It had active volcanoes. One still remains, the largest volcano in the solar system. The cliffs leading to it are over 6 miles high. Mount Everest would sit comfortably in their shadow, and those are just the foothills. This is the awe-inspiring Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. A giant like this takes millions of years to build, time that volcanoes here on Earth never get. On Earth, the crust is always moving. Deep below, a single hot spot pushes magma through the surface, building a new volcanic island. But while the hot spot stays still, the surface is moving. The new island moves away from the hot spot, and a new volcanic island takes its place. Mars is different. The crust is locked solid. On Mars, there is no tectonic activity. The crust is one big solid plate. So if there's a hot spot, it just sits there, building and building, and you get a bigger and bigger volcano. That's why Olympus Mons is so huge. Today, Olympus Mons is a frozen relic of a distant, warmer past. Mars' shrunken atmosphere means that Olympus now reaches almost into space, a true colossus, an extinct volcano on a dying world. But Mars's ancient volcanic terrain could one day harbor life again. The evidence is right here on Earth. On Hawaii, volcanoes have created mysterious tunnels called lava tubes, channels left behind when torrents of molten rock surged into the sea. Some are now empty, and that offers us an opportunity. Lava tubes are formed when you have an underground river of hot basaltic lava, 2,000-degree magma, molten rock. Picture it like a frozen river of water with an ice crust forming on top. It's the same thing here, only the crust is solid rock, and the river keeps flowing underneath, creating this cave, this lava tube. Recent images suggest that Mars's volcanoes may have also created lava tubes. Any planet with basaltic volcanism, any rocky planet, will probably have lava tubes, and we've now found a couple of them on Mars in places where there are skylights, spots where the roof has collapsed, and you can see directly into the lava tubes from orbit. If some of these tubes have collapsed, perhaps many others are still intact, ancient relics of Mars's volcanic past. After lying dormant for perhaps millions of years, these lava tubes could bring life back to the red planet, life that would be us. One of the challenges of living on Mars for future humans will be dealing with the radiation environment, especially during solar storms. Cosmic rays can be deadly, and having a storm shelter under a large mass of rock is the best way to protect yourself from these rays. The tubes and caves of Mars's extinct volcanoes could one day make the perfect home, trapping air and shielding us from deadly radiation. A long-dead volcano could help bring new life to the planet. On some planets, storms are impossible. Superheated Mercury is too small and too close to the Sun to have a significant atmosphere, and no atmosphere means no storms. However, if we move farther away from the Sun, we find worlds with turbulent, chaotic atmospheres that can produce some of the most awe-inspiring megastorms in our solar system. This is Venus, a planet completely shrouded in clouds. Winds rip through the upper atmosphere at over 300 miles per hour. About 35 miles above the surface, the winds whip around ferociously, carrying the cloud features around the entire planet every 4 days. Venus is closer to the Sun than Earth, and it's the Sun's heat that drives these winds. The circulation pattern of Venus's clouds is actually quite simple. There's a warm side and a cold side of Venus. As the air warms and rises on the day side of Venus, it spreads around to the night side, forming a continuous current. It's actually much simpler than the atmospheric circulation on Earth. Venus's winds circulate faster than the fastest hurricane on Earth, though they look very similar. The Venus Express probe captured remarkable images of the planet's south pole, showing one of Venus's great mysteries, hurricanes at the poles, especially in the southern hemisphere, with not one but two eyes. We've never seen anything like this on such a planetary scale. Venus's double-eyed vortex is 1,800 miles wide, with two hurricanes swirling around each other. If you could descend into the vortex of Venus, something I'd love to do with a remote machine, I think you'd see a fantastic wall of cloud with a twisting form spinning around you at ferocious speeds. It would be quite a sight. It's a mystery how deep this raging vortex goes, but maybe it descends all the way to the planet's surface. Down there, permanent twilight bathes a volcanic landscape, and the colossal weight of the atmosphere creates immense pressure. The atmospheric pressure on Venus is about 100 times that of Earth. Imagine squeezing a car down to the size of a square inch and putting it on every square inch of your skin. You'd be flattened in a fraction of a second. Because of this extreme pressure, Venus's dense atmosphere creates one of the strangest megastorms imaginable, 4 miles per hour winds with the force of a hurricane. The surface winds on Venus are actually very slow because the planet rotates so slowly. It takes Venus about 8 months to turn once around the Sun. However, the crushing atmospheric pressure packs the gas molecules so tightly that they feel more like a liquid. A gentle 4 miles per hour breeze on Venus carries the brutal force of a hurricane. It's like a hurricane in slow motion. Winds on Venus are totally unlike anything we see on Earth. You'd almost feel like you were moving through molasses, making it difficult to walk or run through the wind. Venus's surface is so hostile that life is impossible here, but the faster winds in the upper atmosphere hold an extraordinary possibility. I harbor this idea. I'm not sure if I'd call it a hypothesis or a scientific fantasy, but I do think it's plausible that there could be some form of life living in the clouds of Venus. There are certainly energy sources, such as sunlight, and there are nutrients, carbon, hydrogen, and oxygen, all the elements we think are needed to create life. These exist in Venus's clouds. Earth's upper atmosphere is full of life, with microscopic bacteria drifting on the wind. Could Venus be the same? Perhaps one day we'll send a probe to find out. Leaving Venus behind, the next planet is Earth. Here, the weather can also be extreme. We face tornadoes, hurricanes, and dust storms. On Earth, these storms are localized, but on the next planet out, they engulf an entire world. Over 100 years ago, astronomers thought they had found life on Mars when they saw a dark wave spreading from the pole toward the equator. They believed it was springtime vegetation spreading across the planet. While they were right about the season, Mars is tilted roughly 23 degrees, like Earth, so it has seasons like spring, summer, fall, and winter, which bring weather. The shadow the astronomers saw was actually dark rock uncovered by a violent dust storm, driven by the way Mars tilts. On Earth, it takes 1 year to orbit the Sun. In January, the northern hemisphere leans away from the Sun, giving us winter, and in June, it leans inward, bringing summer. Mars experiences gigantic planetary dust storms that we have never seen on Earth. Mars has a similar tilt, and with springtime comes storms. The Martian surface disappears beneath clouds of raging dust particles. On Earth, dust storms can be devastating, swallowing entire cities. On July 5, 2011, a 5,000-foot-high wall of dust smashed into Phoenix, Arizona, turning day into night as thousands of tons of dust settled over the city. But this disaster stayed in one place. Mars's dust storms, however, can engulf the entire planet. When dust is kicked up on Mars, it can keep getting kicked up again and again. The dust is reusable. On Earth, once dust is kicked up and settles out, it often falls into the ocean, where it's gone for good. On Mars, there is no place where dust and sand aren't ready to fuel the storm, allowing these systems to last for weeks or even months. Mars's incredibly dry atmosphere adds to the storm's size and power. On Earth, dust is rapidly washed out by rain and carried into the ocean. But on Mars, there is no comparable rain to wash the dust away. Once it's in the atmosphere, it stays there until the particles slowly settle out on their own. The lack of rain allows Mars's dust storms to cover the entire planet. But dust storms on Mars can also be spectacular on a smaller scale. NASA's rovers captured extraordinary images of dust devils sucking up fine, dry iron oxide dust. The largest dust devils can reach 6 miles into the sky, pumping fine particles high into Mars's atmosphere, creating a dust haze that may help control the planet's dry climate and potentially lead to a planet-wide megastorm. Even on Mars, such large dust storms are rare. Astronomers have detected only 10 in the last 100 years. What the ancient astronomers mistook for life was actually a megastorm. But even a planet-encompassing dust storm is dwarfed by the weather on the next planet from our Sun. This is the giant of our solar system, Jupiter. Jupiter is enormous, 2.5 times more massive than all the other planets in the solar system combined. It's also home to gigantic megastorms. Jupiter's high-speed rotation drives vast bands of counter-rotating clouds, where colossal storms form along their boundaries. The biggest of these is the oldest storm in the solar system, 15,000 miles across and over 300 years old, the Great Red Spot. Along its edges, turbulent winds rage at over 300 miles per hour. The Great Red Spot is a giant vortex, similar to a hurricane, with a high-pressure center and winds swirling around the outer edge. In this way, the Great Red Spot is a bit like a hurricane, but with one key difference. On Earth, hurricanes feed off heat from the ocean, and when they hit land, they start to weaken. On average, they last only about a week. Jupiter, however, doesn't have land. It's a completely gaseous planet, where friction is very weak, so a vortex like the Great Red Spot can last indefinitely. There's nothing to slow it down. To keep going, all the red spot needs is a power source. On Earth, that power comes from the Sun, but Jupiter is 5 times farther from the Sun than we are, so the Sun's heat isn't enough to drive the red spot. Instead, Jupiter has its own internal power source, its immense gravity. In 1995, NASA launched a probe straight toward the giant planet's heart. It plunged into Jupiter's upper atmosphere at over 106,000 miles per hour. As it fell, the planet's crushing gravity increased the pressure 10, 15, 20 times what we feel on Earth. Winds gusted to over 400 miles per hour. The probe gave out just 100 miles in, crushed by the immense pressure and fried by the incredible heat. If it had made it deeper, it would have reached a vast silvery ocean. Here, intense pressures turn hydrogen gas into a churning metallic liquid, superheated to over 40,000 degrees Fahrenheit. Jupiter's interior pumps out about twice as much energy as its surface receives from the Sun. This internal heat is the power source driving its massive megastorms. All of the convection and heat comes from the hot, dense interior of the planet itself. The bands of clouds that you see, even counter-rotating in different directions, are all driven by Jupiter's internal heat. Jupiter's internal heat drives its violent megastorms, but the giant planet may hold clues to an even deeper mystery. Could life exist on other worlds? NASA's Cassini probe studied Jupiter as it flew past en route to Saturn and made an extraordinary discovery: strange white clouds just north of the Great Red Spot, clouds just like those on Earth, made of droplets of liquid water. Could Jupiter have the ingredients for life? The question of life on the giant planets is an interesting one. You have many of the ingredients for life: sunlight coming in and liquid water, at least in the form of cloud droplets. On the other hand, if life could easily exist in clouds, you might expect that bacteria and algae would populate the clouds on Earth, turning them green. But we don't see that. We do, however, find microbes at many altitudes throughout Earth's atmosphere, but they seem to largely be blown up from the surface. It's likely that life on Earth began on a solid surface, but could life evolve without one? There's no solid surface on Jupiter, which makes it difficult for organisms to have a constant source of water. Imagine being a bacterium inside a cloud droplet. You'd be in deep trouble when that droplet evaporates. Whether life exists in Jupiter's clouds or not, gas giants like Jupiter and its neighbor Saturn have all the right ingredients: water, heat, and one other vital element, a spark. Lightning on an unimaginable scale. These haunting images are from NASA's Cassini probe, which was on a mission to explore one of the solar system's most awe-inspiring planets, Saturn. The probe reveals Saturn's rings, moons, and the planet itself in near-perfect detail. Chaotic bands of clouds race around Saturn at more than 1,000 miles per hour. Finding storms here was no surprise. It's a planet of storms. But this was astonishing: a bolt of lightning, a gigantic thunderstorm on an alien world. Lightning creates some of the most spectacular weather on Earth. Electrical tension builds between the top and bottom of a vast 55,000 feet high storm cloud, a maelstrom of water vapor, rain, and ice. Tiny ice crystals rise past falling hailstones, and as they rub against each other, they build up a charge. When the strain gets too great, an electric spark is released. On Earth, the average lightning storm stretches 15 miles. On Saturn, they can encircle the entire planet. There are examples of lightning storms on Jupiter and Saturn where the anvil cloud, or the large cloud at the top of the storm, starts small and grows to be 20,000 kilometers long. That's the size of Earth. On Saturn, we registered a lightning storm that was 10,000 times stronger than any lightning storm on Earth. Lightning is hotter than the surface of the Sun, and the atmosphere literally explodes, producing the sound we call thunder. On Earth, it's the sound of new life. Lightning seems scary and destructive, but it's actually very productive for life on Earth. The reason is its influence on atmospheric chemistry. Every bolt literally burns the air. When a lightning discharge occurs, you get a very high temperature, energetic plasma, which breaks up nitrogen molecules in the atmosphere, freeing nitrogen atoms to form other molecules. The nitrates formed by lightning allow nitrogen to enter the soil as fertilizer, nourishing plants and entering the life cycle. So, it's lightning that frees up nitrogen atoms, essential for life on Earth. Earth experiences 8 million lightning bolts every day, helping life evolve and spread across the planet. But for Saturn, lightning alone may not be enough. There's nowhere for alien life to live. However, one place in our solar system may solve that problem: Saturn's moon Titan. It has an atmosphere, lakes of liquid methane, and its own bizarre brand of megastorms. Saturn is almost 990 million miles from the Sun, and this far out, orbiting the Sun takes time. Saturn's year is nearly 30 Earth years long. Right now, it's spring, and things are heating up. We're moving into Saturn's summer cycle, so the atmosphere is warming up slightly. Even though Saturn is so distant from the Sun, we're getting just a bit more energy, and we're seeing the most spectacular storms we've ever observed on Saturn. After years of frozen silence, Saturn is coming alive. Scientists have waited nearly 15 years for the Sun to light up its North Pole, revealing extraordinary details about one of the strangest megastorms in the solar system, Saturn's unique hexagonal storm. A hexagonal pattern, how can that be? In nature, we have jagged objects. We don't have geometric figures arranged so precisely, especially on a gigantic planetary scale. However, there are some theories. If I take a bucket of water or a bathtub and vibrate it, I get waves that travel. But there's another kind of wave, stationary waves. Inside a bucket of water, you can get resonances where the water pulsates like this, and you can also get it to pulsate in a circular motion, creating regular patterns. These are called stationary waves, and we think that this mysterious hexagonal pattern on Saturn is a hexagonal standing wave. The megastorm at Saturn's North Pole is a wind that travels at hurricane speed, sharply cornering 6 times as it races around the planet. The central clearing is so large that you could fit 4 Earths inside it. What lies beneath its surface is still a mystery. As Saturn warms from spring to summer, another world comes alive too. One of Saturn's moons, Titan, is also heating up, and with the warmth come storms. Titan is one of the most fascinating moons in our solar system. It's straight out of science fiction, an object with yellow skies and methane clouds. Truly remarkable. NASA's Cassini probe reveals Titan in unprecedented detail: a thick, dense atmosphere, vast mountain ranges, lakes of liquid methane, and an arrow-shaped band of white methane clouds moving over its surface. When the clouds drifted over a dusty open plain, seen here as a dark patch, the dark patch of ground beneath the clouds grew larger. Scientists believe liquid methane drenched the surface, a spring rainstorm, Titan style. Rain on Titan, if it exists, would be very different from rain on Earth. First, the gravitational field is very weak, so you would actually see raindrops falling very slowly toward you. Also, the size of these droplets could be much larger. But don't get caught in a rainstorm on Titan. Those droplets are extremely cold. Titan's methane monsoons sweep across the moon. Weak gravity creates ultra-cold, hazelnut-sized raindrops. An alien world with truly alien weather, these slow drops have carved valleys and lakes, much like those on Earth, a slow-motion megastorm. But fly even farther out through the solar system, and you find storms that are altogether faster. This is superchilled Neptune, where the temperature never rises above 300 degrees Fahrenheit below zero. Neptune is one of these giant planets. It's much larger than Earth and has a very thick atmosphere. It's about 2 billion miles away from the Sun, so you might expect it to be very cold with little weather. But in fact, Neptune is very dynamic. It has tremendous weather patterns. Despite its incredible distance from Earth, astronomers can get a close look at Neptune's turbulent atmosphere with the help of the Keck Observatory. Located 14,000 feet up on the summit of Mauna Kea in Hawaii, it sits above Earth's clouds and pollution. The telescopes are so powerful that they could spot a candle on the moon. At first, Neptune appears featureless, but a closer look reveals white, high-altitude clouds in the upper atmosphere. It's the perfect opportunity to track wind speed. Measuring the time and distance the clouds travel between 2 points allows scientists to clock their speed. The Keck telescope turns toward Neptune. A series of shots track the white clouds as they move around the planet. By taking several photographs showing the clouds' positions over time, we can measure how far they've moved. You can see the position at one moment and then again a few hours later in a different place. Most of that change in position is due to the planet's rotation. However, if you know the rate of rotation and subtract it, you get the motion of the clouds relative to the planet, which tells you the wind speed. The results are shocking. We're seeing wind speeds on Neptune reaching many hundreds of miles per hour, up to 1,260 miles per hour for the fastest clouds. That's truly phenomenal. Neptune has the fastest winds in the solar system. So, what's driving this? You need energy to create weather. Where is that energy coming from? It turns out that it's coming from Neptune itself. While Neptune does receive sunlight, it radiates away a lot more energy than it gets from the sun. This suggests that the planet's interior is very hot, probably because of radioactive materials and leftover heat from when Neptune formed 4.5 billion years ago. That heat is slowly leaking out, heating the atmosphere and driving all of Neptune's extreme weather. Neptune's storms are fierce, but the search for truly extreme weather takes us out of the solar system altogether into uncharted territory. Out here, there are storms that make Neptune's winds seem like a breeze. Hurricanes like Katrina are nothing compared to the winds on Osiris. The search for megastorms leads us to alien worlds whose violence defies imagination. Space is full of stars and planets where chaos and destruction reign. Astronomers search the skies for new worlds, and leading this effort is Professor Jeff Marcy, the king of planet hunters. He scans the night sky, looking for planets around distant stars. Marcy's team has instruments so sensitive that they can even predict the weather on these distant planets. This is Osiris, a planet 150 light-years from Earth. It's a planet from hell with matching weather. Earth is 93 million miles from the Sun and orbits the Sun in 1 year. Osiris, on the other hand, is just 4 million miles from its star, completing its orbit in just 3.5 days. When Osiris passes between us and its star, starlight briefly shines through its atmosphere, giving us a glimpse of the conditions on this alien world. They waited for the planet to pass in front of the star, and at that moment, some of the starlight passed through the planet's atmosphere. This allowed scientists to perform a chemical analysis of the atmosphere's composition. Osiris is blasted by the intense heat of its star, with temperatures exceeding 2,000 degrees Fahrenheit. This means the environment on that planet is utterly inhospitable to life as we know it. But even more intense is the effect of the heat, which causes the gases to expand, and with nowhere to go, they rush to the backside of the planet. Osiris is tidally locked, meaning the same side always faces its star, while the other side looks into space. The temperature difference is immense. Superheated atmosphere roars from the bright side to the dark side at nearly 6 times the speed of sound. In fact, the winds reach speeds of 2,000 to 3,000 miles per hour, 10 or 20 times faster than the strongest hurricanes. Katrina was just a sneeze compared to the winds on Osiris. But there are even larger megastorms, storms on the scale of entire galaxies, and these vast storms may be the reason any of us are here. The Hubble Space Telescope captured this stunning image of the galaxy NGC 3079. At its center, a superwind, a storm on a truly cosmic scale, was triggered by an explosion from a forming star. This raging galactic storm is about 3,000 light-years wide and has been raging for around 1 million years. Filaments of 20 million degree gas tower above the spiral galaxy. This cosmic megastorm wreaks havoc within its host galaxy. We see bubbles, jets, and formations of gas falling into the galaxy, colliding with galactic dust. The gas from the galactic megastorm smashes into gas and dust at the heart of the galaxy, compressing it into a swirling mass of matter. Gravity takes over, and the compressed clouds of gas and dust get tighter and tighter. The center becomes hotter and hotter until it finally ignites. Powerful winds from the new star blast into space, and the whole cycle begins again. A new galactic megastorm is born. Around the fledgling stars, dust and rock come together, marking the birth of new worlds with rocky surfaces where life could begin. Perhaps the formation of life itself is influenced by how these gases swirl and create supergalactic storms. If galactic winds blow material around, they help distribute the elements necessary for life throughout the galaxy. So, in some sense, galactic storms may be a clue to the formation of life itself. Galactic megastorms rage for millions of years. Billions of years ago, they may have created new homes for life in our Milky Way galaxy. On every scale, storms are not just a force of destruction, they are linked to creation itself. The search for life on other worlds is also the search for storms. When you disrupt the status quo, you open possibilities for things to reassemble in different ways. Chaos or disruption is actually an important factor in the development of complex systems, like life. A planet that experiences changes of seasons, volcanism, or intense storms, factors that might seem damaging to life, could, in the long run, make life stronger. Look out at the cosmos, with billions of galaxies and trillions upon trillions of stars, and one profound question arises: is anyone else out there? We want to find another Earth. Is there a pale blue dot orbiting some star out there in the galaxy? The search is on for worlds that could harbor life. We're searching for our own vision of ourselves out there in space, searching for our heaven. So far, we've already discovered more than 700 planets beyond our solar system. Yet, these exoplanets look nothing like our own. We were wrong in our assumptions. All the solar systems we're finding out in space don't look like our solar system at all. We are the oddballs. We're the freaks. These are nightmare worlds, and the cosmos is full of them. We're discovering all different flavors of hell, planets that go wrong in various ways. That's where we are right now, searching for heaven and finding hell. Could we really be alone, a cosmic fluke in a universe hostile to life? We may soon have the answer. We have now discovered hundreds of exoplanets in outer space, at the rate of over 1 exoplanet per week. In a few years, that number will likely be in the thousands, and eventually, there could be millions or even billions of these planets waiting to be discovered. Could all of them be planets from hell? The quest for answers starts here, 63 light-years from Earth. We've discovered a planet even larger than Jupiter, and it has a serious problem: its orbit is incredibly tight. It's closer to its star than Mercury is to our Sun, and 30 times closer than Earth. The result is a superheated hell. But there's another reason why nothing could survive here: the ferocious wind. The surface is battered by a never-ending storm. We can't see these winds with our telescopes, but we know the superstorm exists because of NASA's Spitzer Space Telescope. Spitzer can see things that we can't. It doesn't use visible light. Instead, it sees in infrared, a part of the light spectrum we can't see with our eyes. Infrared is heat. One advantage of studying the universe in the infrared is that it allows us to see the light coming from planets around other stars. When you try to look at the light of a planet next to a star, the star is hundreds of thousands of times brighter, rendering the planet very faint. But in the infrared part of the spectrum, the internal heat of the planet, just as our internal heat makes us glow, allows the planet to become observable and measurable. Spitzer gives us something completely new: the very first weather map of a planet beyond our solar system. This simple image is a technological triumph. The colors represent temperature differences, and the map also proves the planet has hellish winds. That's because the hot spot isn't where it should be. One side of the planet permanently faces the star, so its center should be the hottest point on the planet. It isn't. Something pushes the planet's hot spot to the side, and that takes incredible force. Only a non-stop 6,000 miles per hour hurricane could be this powerful, 20 times stronger than the strongest winds on Earth, and 8 times the speed of sound. A small shift on a weather map is evidence of supersonic winds raging on an alien planet, truly a planet from hell. We're finding new planets at a staggering rate, averaging 1 per week. Each one could potentially be an Earth-like heaven, but the more we explore them, the more hellish worlds we find. Some are so nightmarishly hot that they're more than uninhabitable, they shouldn't even exist. This Jupiter-sized gas planet, 256 light-years from Earth, shines in infrared like a star, thousands of times brighter than Venus, the hottest planet in our solar system. It's a blistering 3,700 degrees Fahrenheit. It's nearly impossible for a planet to get this hot. Its hellish temperature provides a clue to its appearance. Only an absolutely black object could absorb enough light from its star to reach such scorching temperatures. If you were approaching the night side, away from the star, you would see only darkness in front of you, very little radiation, very little light. It would almost seem as if the stars were avoiding a part of the sky. Just as black pavement absorbs sunlight and heats up on a sunny day, the black planet roasts beside its star. We don't understand its atmospheric chemistry. There's nothing on Earth that can absorb so much light. The planet's only color comes from a scorching hot spot. As you fly around to the day side, things would begin to glow red-hot. There'd be a huge swirling storm, all red and glowing. What a hellish world. Deep inside, clouds of titanium oxide swirl around a solid core 100 times heavier than Earth. Darkness made visible, another world from hell. But some planets are even bigger, presenting seemingly impossible puzzles. Here's a mystery. Every astronomy textbook says that gigantic Jupiter-sized planets form far out in space, where it's really cold. So why is a Jupiter-sized planet inside the orbit of Mercury? Jupiter-type planets can only form far from their parent stars, out in the cold reaches of space. A gas giant orbiting this close means that these monsters can move. This is WASP-12b, a scorching vision of hell. It's so close to its star that its orbit lasts just one Earth day. This world is so hot, over 4,000 degrees Fahrenheit. It's insanely hot. WASP-12b is one of the hottest planets in our galaxy. We've never seen anything like this before. It's certainly one of the most violent environments in the universe. WASP-12b is only 2 million miles from its star. The searing heat puffs up its atmosphere, giving it the density of styrofoam. In a large enough bathtub, it would float. We actually think it's so close to its star that the gravity, the tidal effect of gravity, warps it into almost an egg shape. It's not even round, it's oblong. Thousands of miles beneath the puffed-up atmosphere lies a solid core. It's rich in carbon, and the pressures are extreme. There could be mountains of diamond and graphite and seas of liquid tar. But WASP-12b won't last long. It orbits so closely that its star is literally tearing it apart, ripping away nearly 190 quadrillion tons of gas every year. 10 million years from now, WASP-12b will vanish. The question is, how did it get so close in the first place? This is the birth of a solar system. In the center, a new star. Around it swirls a disk of microscopic dust grains. These are planets in the making. The dust grains collide, and each time they collide, they merge and grow bigger, like dust bunnies under your bed. Over 100,000 or a million years, they become very large dust bunnies, getting bigger and bigger. Trillions of miles from the star, it's cold enough for ice to form. Ice picks up dust and gas. These gaseous clumps grow larger over millions of years, eventually becoming gas giants. In our solar system, the gas giants, Jupiter, Saturn, Neptune, and Uranus, all formed this way, in the distant orbits where we still see them today. So, how did WASP-12b end up so searingly close to its star? The answer is gravity. This planet is huge, 40% more massive than Jupiter. Its immense gravity disturbs the dust disk it formed from, creating turbulence, and so the planet creates waves in the disk, like density waves, which you can sort of think of as waves on an ocean. The gas giant becomes a galactic surfer. Over hundreds of thousands of years, the planet rides the waves inward toward the star. As the planet gets closer and closer to the star, it starts to feel the radiation from the star more intensely, heating up as it surfs millions of miles from the cold outer reaches of the star system into the tight, scorching orbit we observe today. An ice-cold world becomes a planet from hell. No one had any real clue that you could form a planet a billion miles away from a star and that it could somehow move inward. That's incredible. But that's really the only explanation for how these planets got so close to their stars in the first place. WASP-12b is bizarre, but it isn't alone. We found many of these super-hot, super-close giants, and we call them hot Jupiters. Battered by supersonic winds, blacker than night, hotter than hell, but these hot Jupiters all have one thing in common: there's no life here. These planets are as different from Earth as you can possibly imagine. In fact, we've now found over 100 of these things, making them so common that it raises the question, which ones are the weirdos, these planets or us? This planetary roller coaster has consequences. As they spiral inward, hot Jupiters cause chaos. They create a whole new class of planets from hell, orphan worlds flung away from their star into the emptiness of interstellar space. Planets orbit stars, but between the stars is a vast sea of darkness. We've always thought of space as being empty, which is considered its defining characteristic. That's why we call it space. But when planet hunters switched from gazing at stars to staring deep into space, they made an amazing discovery. Out of the darkness between the stars, planets began to appear. First, one dark gas giant, then several more. Eventually, 10 dark starless planets emerged from the shadows of space. I often wonder what it would be like to be on one of these rogue planets, drifting between stars. The night sky would be perfectly black, dotted with stars, beautiful, but if you were on one of these planets, you would be in a world of perpetual night. There would be no sunrise, no sunset, and no warmth from the sun. These planets once formed around a star, but now they roam the darkness of interstellar space. Their journey here was violent. Each was forced from its home orbit by the gravity of a hot Jupiter. A Jupiter-sized planet is like an 800-pound gorilla. It sits wherever it wants. Hot Jupiters are killers. As they surf inward toward their star, their immense gravity disrupts the system, hurling planets from their orbits. Any small planet unlucky enough to be near its mother star is flung into outer space by a passing Jupiter. These planets will never again feel the heat or see the light of a star. So far, all the rogue planets we've discovered are gas giants, but perhaps there are smaller, rocky worlds too, worlds that were once like Earth. The large, Jupiter-like planets are just easier to detect, but there's no reason to assume smaller orphan planets don't exist. Maybe, as a Jupiter-sized planet moves toward its star, it plays ping-pong with the other planets, and even a planet like Earth could have been kicked out. You would have a cold, frozen little world streaking between the stars, dark and lonely. These planets are victims of a violent gravitational battle, frozen, orphaned Earth twins. There may be hundreds of billions of these planets roaming the galaxy. There are only a couple of 100 billion stars in the galaxy, which means these rogue planets may actually outnumber the stars. Right now, we find at least one new exoplanet every week. As our technology improves, we'll be able to detect smaller and smaller planets orbiting stars, worlds with solid surfaces like our own. But the first rocky planets we found are nothing like Earth. These planets have been through hell and back. We've discovered hundreds of alien worlds, and now, for the first time, we're finding small planets made of rock, just like Earth. Planets this size are potential homes for life, but instead, we're finding more planets from hell, strange, nightmarish, and uninhabitable. This is Cryo 7b, a world of violent extremes, two hells in one. It's so close to its star that the star appears 360 times larger in the sky than our sun. On Cryo 7b, the first hell is unimaginably hot. The surface is a furnace roasting at 4,700 degrees Fahrenheit. Lava boils, turning the atmosphere into vaporized rock. When a cooler front moves in, small pebbles condense, and rocks rain from the sky. If that's not a classic vision of hell, I don't know what is, but that's only half the story. The hot side of the planet is permanently locked, always facing the star. Beyond this is the twilight zone, where temperatures are cool enough to turn the lava oceans into solid rock. But this pleasant zone is narrow. Travel further, and you descend into a second half hell. This is the dark side, the half of the planet that never sees the sun. Here, there's eternal darkness and savage cold, with temperatures hundreds of degrees below zero. So, one side is blistering hot, and the other is freezing cold. You have fire or ice in the extreme, the hottest places and the coldest places in the universe. You couldn't think of a worse place to end up. But the planet wasn't always this way. Turn back the clock 1.5 billion years, and Cryo 7b is still forming, but it's not rocky, it's a gas giant, 100 times bigger than Earth. As it migrates closer to its star, the star blowtorches the gas from the planet. Its gaseous shell blasts off into space, revealing a rocky core. Cryo 7b is the skeletal remains of a hot Jupiter. Its parent star has reduced this once massive gas giant to a rocky cinder. It's hard to imagine planets more extreme than Cryo 7b, yet they do exist, rocky worlds bombarded by deadly cosmic rays. One such world orbits a pulsar, 7,000 trillion miles away from Earth. A pulsar is a kind of cosmic lighthouse. This unbelievably tiny world, just 10 miles across, fires an intense beam of radiation through space as regularly as an atomic clock. A single cubic centimeter of this star, the size of a keyboard key, has as much mass as Mount Everest. Imagine smashing Mount Everest into a cubic centimeter. The whole star, just 10 miles across, is like that. It's one of the most hostile environments in the universe. Anything nearby is hammered by intense gravity and magnetism. No one expected to find planets here, but this pulsar has 3 small, rocky, near-Earth-sized planets. They were the first exoplanets ever discovered and are the last place you would ever expect to find life. The pulsar has a tremendous magnetic field and blasts out X-rays, so these poor planets are just getting cooked by radiation. The term Earth-like doesn't really apply to them at all. The X-ray beam strafes the planets over and over, firing radiation 1,000,000 times more deadly than medical X-rays, slowly stripping their surfaces away. These are sterile worlds. Everybody agrees there's no chance for life, at least as we know it, on the planets orbiting the pulsar. The radiation cooks pulsar planets to death. The opposite kind of hell is no better, frozen worlds too cold for life. In the constellation Scorpius, 20,000 light-years away, is a red dwarf star. Red dwarfs are tiny and relatively cool, and this planet is too far away to benefit from what little heat there is. It's so distant that its orbit lasts 10 Earth years. It is the coldest planet we've found in the universe. Its surface temperature is a frigid 370 degrees below zero. This is a world made entirely of ice. Methane, ammonia, and nitrogen, which are gases on Earth, form a frozen, toxic frost here. Glaciers, canyons, and cliffs of ice are the only terrain. Hell has truly frozen over. Our search for Earth's elusive twin reaches another dead end. Perhaps we are truly alone. Or will our first tantalizing glimpses of an alien world potentially perfect for life change everything? Earth is the only habitable world in our solar system, but in a galaxy of hundreds of billions of stars, can we really be alone? It's a question that planet hunters are trying to answer. In my opinion, the whole purpose of the discovery of exoplanets is to establish our true place in the universe. Who are we? Where do we belong in the cosmic scheme of things? Are there other planets that can support life just like ours? That's where NASA's Kepler Space Telescope comes in. Kepler lets us calculate how far a planet is from a star, which is critical for figuring out whether it could sustain life. Life on Earth is only possible because we are at the perfect distance from the sun, not too hot and not too cold, just right for liquid water, oceans, rivers, lakes, rain, and life. You know how journalists say, follow the money? Astronomers say, follow the water, because water is the universal solvent that dissolves most chemicals, and it's where DNA got off the ground. Where there's liquid water, there could be life. We're looking for planets that are not too close to their parent star, where all the water would boil away, and not too far away, where all the water would freeze. We're searching for that Goldilocks zone, where the temperatures are just right for liquid water to pool on the surface. Once Kepler identifies a new planet, astronomers check whether it lies in the habitable zone of its parent star. So far, Kepler hasn't found a single confirmed Earth twin, but it has identified more than 2,000 planetary candidates. And it's this sheer abundance of planets that gives scientists hope. The important thing to remember is that, even though we're finding all these terrible planets that are completely unlivable, we're finding lots of them, hundreds and thousands. This tells us that planets are easy to make, and that means even rare ones are likely to be out there in large numbers. Even if Earth is a rare, precious jewel in our galaxy, there may be dozens or hundreds of them out there. Kepler has opened our eyes to a universe full of planets. We can now estimate how many there might be in our own galaxy, 50 billion. 50 billion worlds, just waiting to be discovered. We think 1% could be in the Goldilocks zone of their star. That's 500 million planets, each with a chance of harboring life, right here on our own doorstep. We haven't found one yet, but we're getting closer. This is Gliese 581, a red dwarf star 20 light-years from Earth. Gliese 581 is a tiny little star. If the sun were as bright as a 100-watt light bulb, then Gliese 581 would be like a little Christmas tree light, a tiny, fairy light, very, very small. This shifts the habitable zone inward because, to be warm enough, you need to snuggle up right next to the star. The star has 4 planets. 3 are too close and too hot for liquid water, but the 4th is different. It's a rocky world, twice the size of Earth, and it's right on the edge of the Goldilocks zone. In theory, if the planet has a thick carbon dioxide atmosphere, it could trap enough heat to have clouds, rain, and oceans. It would be a strange place to live, with twice Earth's gravity, bathed in permanent red twilight. But right now, this weird world is the closest we have to a planet like ours. It's a promising start. When we actually know for a fact that up there, around that star, is a planet like Earth, it's going to fundamentally change how people look at the sky and how they perceive their place in the universe. That will be a profound moment, not just for me, but for humanity in general. Our goal is to find another Earth, but along that path, we are going to discover more things than we could have ever possibly imagined. That's the part one love the most about this. We don't know what craziness will be around the next corner when we're searching for more planets. I can't even imagine. 2 decades ago, the only planets we knew were right here in our solar system. Now, there are hundreds, all very different from our home. The universe is filled with hellish worlds, super hot, ultra cold. An ordinary starfield, but home to one of the most extraordinary stars in our galaxy. 8.7 light-years from Earth, this is UV Ceti. This mysterious object can grow 5 times brighter in less than a minute. Any planet circling this star would be blasted by the heat, quickly melting its frozen surface. Then, just seconds later, the star dims, and the planet retreats into icy darkness. But UV Ceti is about to go even further. The star begins to brighten again, but this time it doesn't stop. A runaway inferno, in just 20 seconds, it gets 75 times brighter than normal. UV Ceti has unleashed a mega flare, an immense explosion of energy on the star's surface. If our sun fired off a mega flare like this, we'd be toast. If you were standing on the surface of the Earth and the sun became 75 times brighter, even for only a minute or 2, it would probably be the last thing you'd ever see. The temperature on Earth would rise dramatically, causing huge fires. It would essentially cook everything. Earth is a long way from UV Ceti, so we're safe from that particular star, but the more stars we study, the more flares we find. They fire in all directions, and sometimes directly at us. The closer a star is to Earth, the greater the danger, and one star is much closer than all the others, our Sun. The Sun looks stable and calm, but behind the glare, it's a monster. Solar observatories capture its violence. Flares erupt across its surface in gigantic explosions on an unimaginable scale. One flare, one of the most energetic on the Sun's surface, would be equivalent to over 200 million hydrogen atomic bombs. That's enough energy to power the entire human race's energy consumption for something like 2 million years. Each flare is as bright as 400 billion trillion light bulbs, but the visible light is just a fraction of the energy it emits. Radio waves, infrared heat, ultraviolet light, and even X-rays are unleashed in every flare at incredible intensities. These are the biggest explosions in the solar system, yet the force behind them is simple: magnetism. The Sun has an immense magnetic field, and the energy stored in this field powers solar flares. Vast loops of magnetic force push toward the surface, and huge magnetic arches rise out into space. When two magnetic field lines cross, it triggers a magnetic short circuit. This is a solar flare. All the energy trapped in the magnetic field blasts out at 100 million degrees, and it can hurl hot gas a billion miles out into space, in an eruption 10 million times more powerful than a volcano. Magnetism, the same force that powers a simple compass, fuels the biggest explosions in the solar system. Yet, by cosmic standards, our Sun is puny. As we look out into space, we see even more active stars with even more intense magnetism, and things really start to get wild. There are stars and objects in our galaxy and in other galaxies that produce flares of such great intensity that they could literally destroy all life on Earth if they were nearby. Outside and inside our solar system, titanic explosions rock the cosmos on a scale we can barely imagine. Far beyond the Sun, we enter the realm of mega-flares. Our Sun is violent, its flares explode with the force of billions of atomic bombs, but out in the cosmos, the explosions get even bigger. Other stars have flares so huge, they're planet killers. EV Lacerti, 16.5 light-years from Earth, experiences flares erupting on its surface every day. But one mega-flare smashed every record, blasting out 10,000 times more X-rays than the Sun's most powerful flare. The ultraviolet light was so intense that the star turned blue. This stellar firestorm, 100 trillion miles away, was visible from Earth with the naked eye. If our Sun flared like this, we'd be incinerated. But EV Lacerti is a very different kind of star compared to our Sun. It's tiny. This is a red dwarf. Red dwarfs are stars that have much less mass than the Sun. They can be a tenth to about 4/10 the mass of the Sun. They're smaller, cooler, dinky stars that burn so slowly that, unlike our Sun, which will last 10 billion years, some of them will last 10 trillion years. They're also relatively cold. Their surface is just 5,000 degrees Fahrenheit, half the temperature of our Sun, and they're 10,000 times dimmer. Yet somehow, they are capable of staggering violence. That's because red dwarfs are immensely magnetic. The fields that form inside them are enormous, much more powerful than our Sun's. That means the magnetic field energy that can be released when those fields get twisted up is incredibly intense, and even though these stars are very dim in visible light, they can produce flares that are thousands of times more energetic than those released by the Sun. You wouldn't want to be near one when it flares. All red dwarfs flare violently, but EV Lacerti's flares are off the charts. That's because it's young, just 300 million years old, 15 times younger than our Sun. In one way, stars are a little like people. They're hotheads when they're young. When stars are first born, they spin very rapidly, which helps generate magnetic fields. The result is a star 100 times more magnetic than the Sun. When its giant loops of magnetic energy cross, The resulting mega flare is colossal, a torrent of radiation lasting 8 hours. Big flares on our sun have the energy of billions of atomic bombs, but E.V. Lacerti's monster flare was 10,000 times more powerful. Incredibly, even these massive flares are just a flicker on the cosmic scale. There are eruptions millions of times brighter, explosions that can light up a whole galaxy, from a tiny star with unimaginable power. This is the Australia Telescope Compact Array, a network of 5 radio dishes constantly listening to the cosmos. In 2004, they were struck by a massive blast of energy, evidence of a mega flare. But this was bigger than anything we had witnessed before, the largest burst of power ever recorded from our galaxy. The object behind it is truly bizarre, a kind of star we didn't even know existed until a mega flare gave it away. I've studied black holes, stars that explode, and rogue planets wandering the galaxy, but in my opinion, the scariest single object in the galaxy is a magnetar. Magnetars are the most magnetic objects in the universe, and this one beats them all. Its magnetic field is 1,000 trillion times stronger than our sun's. If it came near our solar system, the effects would be devastating. The first thing you would notice is its magnetism wiping every credit card in your pocket. As you get closer, anything metal on you, your earrings, your jewelry, would be ripped away. Once you are within a few million miles of the magnetar, its magnetism would be so intense that it would disrupt the electrical signals in your nerves, and your heart would stop beating. Get even closer, and the magnetism would be so strong that it would rip apart every atom in your body. Amazingly, this vast magnetic field comes from an object no bigger than an asteroid. Our sun is close to 1 million miles across, but the magnetar is just 10 miles in diameter, yet it's unimaginably dense. It weighs more than the sun. This is incredible. Imagine taking the sun and squeezing it down, not just to the size of the Earth, but down to the size of Manhattan. The entire mass of a gigantic star packed into the size of a city. You could almost walk around the star in a day, except you couldn't because the gravitational field is so intense. The density of material in these stars is so great that a teaspoonful would weigh several thousand billion tons. You would be crushed beyond recognition in an instant. Dense and compacted, the iron-rich crust is under incredible magnetic pressure. Something has to give. Fissures rip across the surface, and the crust splits open. This is a starquake. It's like an earthquake on Earth, except the crust only shifts by half an inch. But that tiny movement releases a huge amount of energy due to the star's intense gravity. It's like a magnitude 30 earthquake. A flare erupts from the fracture. A trillion-ton cloud of ultra-dense matter blasts into space. The flare lasts just 1/10 of a second but unleashes more energy than the sun emits over 250,000 years. The energy released by these flares from a magnetar can be more than 1 billion times the energy emitted by the sun. These mega flares act like time machines, showing us events from long ago. This magnetar is 50,000 light-years from Earth. The flare we observed in 2004 actually happened 50,000 years ago. It took that long for the light to travel halfway across the galaxy and reach our atmosphere. If a similar mega flare exploded near Earth, we wouldn't even see it coming. There would be no warning. If a magnetar were to have another flare like this, the event is so sudden and releases so much energy that it blasts out at the speed of light. Since nothing travels faster than light, we would simply be hit by it. Any life within 10 light-years of the blast would be vaporized. Thankfully, even the closest magnetar is too distant to threaten us. We can't see them, even with the strongest telescope. We've only detected these stars during the flash of a mega flare. Yet these explosions are dwarfed by an even more powerful monster, second only to the Big Bang in scale. This is the ultimate mega flare. 7.2 billion years ago, in a galaxy far away, a supergiant star was in trouble. Its nuclear core had run out of energy, and it was about to implode. For a few seconds, the colossal blast shines 1 million times brighter than our entire galaxy. This is the most extreme explosion in the universe, a gamma-ray burst. Gamma-ray bursts are so powerful that they can be seen across the entire universe, second only to the creation of the universe itself. Two intense jets of energy shoot out. These two beams of gamma rays are the ultimate mega flare. The energy they contain is just unimaginable. It's the entire power that the sun puts out over its 10 billion-year lifetime, concentrated into just a few seconds. It's like a cosmic blowtorch of gamma rays and matter cutting across the universe. Gamma rays are the most high-energy light in existence, naturally produced by objects that are billions of degrees hot. There will never be a hotter type of flare. This is where it stops with gamma rays. After 7.5 billion years, we finally see the explosion in our skies. March 2008, a flare from halfway across the entire universe shines even more brightly than the nearest stars. Something blew up 7 billion light-years away that you could see with the naked eye on a dark night. That tells you just how powerful it was. It's the biggest flare ever witnessed, but it's also a sign of the birth of the most destructive entity in the universe. A black hole has formed in the core of the collapsing star. It consumes the star from the inside out, and when the star finally explodes in a catastrophic supernova, all that remains is a newborn black hole. Usually, when we look into space, we see old black holes, ones that have been around for millions of years. But to witness the birth of a baby black hole, that is an incredible event, and that's what we think a gamma-ray burst is. Amazingly, these gigantic explosions are common. We detect more than 350 of them a year, and our satellites catch them every few hours from all directions outside the Milky Way galaxy. Gamma-ray mega flares reveal one of the universe's most awe-inspiring secrets: a new black hole is born every single day. Most of these explosions happened a long time ago, far from Earth, but if one went off inside our galaxy, it could be catastrophic. If a gamma-ray burst occurred just 100 light-years from Earth, it would be like igniting a 1-megaton nuclear bomb over every square mile of Earth's surface facing that event. It would be as if millions of nuclear weapons were exploding over the planet. It would mean the end of all life on Earth as we know it, forever. Gamma-ray bursts are the most powerful mega flares in existence, but they are not the most dangerous to us. The greatest threat to Earth sits terrifyingly close, right at the heart of our own solar system. We were once blissfully ignorant, thinking we were safe in our solar system. Now we know Earth sits in a cosmic firing range. Monster mega flares are everywhere we look. But the deadliest cosmic weapon of all is right on our doorstep, our sun. We're led to believe that the sun is static, benevolent, and friendly. But that's wrong. The sun is dynamic. In some sense, it's alive. It creates magnetism on a scale we can hardly comprehend, and its most powerful weapon is this: a coronal mass ejection. A colossal solar explosion rips a chunk of the star away and hurls it into space. CMEs are related to solar flares, but they're even larger. You can think of a solar flare like a tornado, very powerful, very intense, and short-lived. A coronal mass ejection, however, is like a hurricane, much more energetic, much bigger, and lasting for days. CMEs start with a magnetic short circuit. Magnetic arcs emerge from the sun's surface, glowing with trapped solar energy. When the loops cross, they trigger a firestorm of energy, and the sun erupts. Solar matter explodes from the surface and is hurled into space, a monstrous cloud of superhot gas and charged particles. When one of these massive prominences is ejected, it releases the energy equivalent to about 10% of the sun's total luminosity for a second, directed toward Earth. Over 10 billion tons of material are shot out at speeds exceeding 1 million miles per hour. The power of a CME is truly staggering. While it takes our spacecraft years to travel from Earth to the Sun, a CME can cross that distance in just a couple of days, sometimes in only a few hours or even faster. These are immensely powerful events. Powerful, but also deadly, because sometimes the Sun fires a CME directly toward Earth. The electrically charged cloud wreaks havoc on our electronics, melting power grids, blowing fuses, and disrupting communications. But that's nothing compared to the devastation a really big CME could cause. Such an event could wipe out satellites, GPS, the internet, and disrupt all sorts of critical systems. When this massive solar storm hits Earth, the damage to satellites alone would amount to $100 billion. Imagine a blackout not affecting just one city, but hundreds of cities across the planet. Earth's total property damage would reach about $2 trillion. We could be thrown back 50 or even 100 years into the past, into a world without electricity. Major solar storms are rare. On average, a massive CME strikes Earth every 500 years, but it has happened before, and it will happen again. In 2003, one of the largest coronal mass ejections ever recorded occurred, but fortunately, it missed Earth. One day, however, one of these rifle bullets will be aimed directly at Earth, and at that point, we'll need to be on high alert. Our planet is not only under threat from mega flares in deep space, but also from our own sun. The sun fires billions of tons of hot gas and charged particles into space every day, sometimes sending them straight toward us. What I find amazing is that Earth sits in the middle of this cosmic shooting gallery, yet we have survived this onslaught. We are protected by Earth's magnetic field. It's incredibly weak, but it's enough to keep us safe. Think of a regular refrigerator magnet that has more magnetism than Earth's magnetic field. Without this magnetic shield, every CME would strip away Earth's atmosphere, and we'd be fried by solar radiation. How do we know this? Because it happened to one of our neighbors, Mars. Mars is an example of what happens to a planet without a magnetic field. It's now a frozen desert with an atmosphere that's only 1% as dense as Earth's, because it lacks a magnetic field. Over billions of years, solar particles stripped away Mars's air, which is why its atmosphere is so thin now. Here on Earth, we have a magnetic field, and we have air. This is no coincidence. We can breathe because of our magnetic field. From Earth's surface, safely beneath our magnetic shield, we can witness the power of our violent sun in the form of the northern and southern lights. Trillions upon trillions of charged particles strike Earth every second. The magnetic shield funnels them to the poles, where they energize gas molecules in our atmosphere, making them glow. It creates a spectacular chemical light show. Oxygen shines green, and nitrogen glows blue or red. The auroras are evidence of a battle between magnetic fields. The sun's magnetic field creates coronal mass ejections, and Earth's magnetic field shields us from them. Magnetism is one of nature's most mysterious forces, and only now are we beginning to understand how it shapes the cosmos. Mega flares make magnetism visible, shining a light on the incredible power of magnetic fields. These fields play a fundamental role in the universe, imposing order on chaos, weaving through the spiral shapes of galaxies. They stretch across hundreds of thousands of light years, yet they are 100,000 times weaker than Earth's magnetic field. Smaller magnetic fields exist within galaxies, organizing matter into molecular clouds and spectacular nebulae. These stellar nurseries are where new stars are born. We have now discovered that magnetic fields even permeate empty space, fields created during the Big Bang with just 1/4 the strength of Earth's magnetic field. This is a magnetic universe, and what's amazing is that despite being invisible, magnetic fields play a crucial role in every aspect of the universe. They protect us from solar radiation, influence the explosions of red dwarfs and magnetars, and impact the most energetic and violent processes in the universe, such as gamma-ray bursts. Magnetism affects the dynamics of objects on every scale, making the universe a violent and fascinating place. Mega flares illuminate the cosmos, revealing things we could not otherwise see, whether from the far side of the universe or from billions of years in the past. In a flash, they expose distant events and hidden mysteries. A black hole is born, a star dies. These flares reveal the awesome secrets of the universe, shedding light on its most incredible and enigmatic phenomena.